again exercise 10.4, question 21E, and this question says to find the greatest coefficient of 2x squared minus 3 over x to the power of 11. So again, we're going to find the k plus 1th term. Now we know that that is 11c to the k. Then we've got 2x squared to the 11 minus k. Then we've got minus 3 over x to the power of k. Now that is 11ck. We're going to break this up. We've got 2 to the power of 11 minus k, x squared to the power of 11 minus k. Now this is negative 3 to the power of k, and that is x to the minus 1 to the power of k. So it will be x to the negative 1 to the power of k. Now simplifying this, we've got 11ck, 2 to the power of 11 minus k. Expanding this, we've got x to the power of 22 minus 2k. Again, we've got negative 3 to the power of k, and we'll have x to the power of negative k. Okay, now for the kth term, so t to the k. Now notice the k plus 1 is 1 higher than this k here, so it'll be 11c to the k minus 1. 2x squared to the 11, it'll be that minus that, 11 to the k minus 1. And we've got negative 3 on x to the k minus 1. So that will be 11c to the k minus 1. We've got 2x squared again to the power of 11 minus k plus 1, so it's 12 minus k. Just be very careful there. It really is very easy to make a mistake, and a lot of people will write 10 minus k here. So it's 11 minus k plus 1, which is 12 minus k. Then we've got negative 3 to the power of k minus 1, and again we've got x to the power of negative 1 to the power of k minus 1. So simplifying this, we've got 11c to the k minus 1. Now breaking this up again, we've got 2 to the power of 12 minus k times x squared to the power of 12 minus k. Negative 3 is to the power of k minus 1, and this x will be to the power of negative k plus 1. Okay, just be careful there again. And again, expanding this, we've got 11c to the k minus 1, 2 to the power of 12 minus k times x to the power of 24 minus 2k. Again, negative 3 to the power of k minus 1, and x to the power of negative k plus 1. Okay, now we're going to look at, we can write it here if we want, for greatest coefficient. Actually, no, we'll just do t to the k plus 1 over t to the k first. Okay, and then we'll do that other bit next. So just looking at t to the k plus 1 over t to the k. Now that is 11ck times 2 to the 11 minus k, x to the power of 22 minus 2k times negative 3 to the power of k, x to the power of negative k, over 11c to the k minus 1 times 2 to the power of 12 minus k, x to the power of 24 minus 2k, negative 3 to the power of k minus 1, and x to the power of negative k plus 1. Now look, we can do this the long way, or we can do it the short way. So 11ck over 11c to the k minus 1. Now comparing 2 to the power of 11 minus k and 2 to the power of 12 minus k, as I said before, just give k any value, like 3. This will be 2 to the 9 over 2 to the 8. You've got one more power of 2 on the denominator, so we go times 2. Looking here, you've got a higher power here. Just give k any value again, like 2, for example. If k was 2, that would be x to the 20, and if k was 2 here, it would be x to the 18. So you've got an extra x squared down here. Again, looking at our negative 3s, negative 3 to k is 1 power higher, so put a negative 3 up here. And x to the negative k and x to the negative k plus 1, this power here is 1 bigger. Oh, actually, we better be careful. Let's try a value. If k is negative 3, this would be negative 3 plus 2. That's negative 3, that's negative 2. negative 2 is higher. Of course, the k plus 1 is higher than the k. So we've got an extra power of x on the denominator there. Okay, now, so we've got 11c to the k. Oh, I'll put the negative 3 at the front. So we've got negative 3 times 11c to the k over 11c to the k minus 1. I'll put the 2 out the front. And I've got the x cubed down there. Okay, now I'm interested in the coefficient. Okay, but before I do that, I'll just compare, I'll just simplify the 11ck over 11ck minus 1. So we've got that equals negative 3 times, and I'll put the 2 down there. Now 11ck is 11 factorial over 11 minus k factorial times k factorial, and we're dividing it by 11 factorial over 11 minus k minus 1 factorial times k minus 1 factorial, or times, flipping it, we get 11 minus k minus 1 factorial times k minus 1 factorial over 11 factorial. Okay, it's just easier to do it there. So therefore the 11 factorials cancel, and we've got negative 3 over 2. Now 11 minus k minus 1, 11 minus k, it'll be 11 minus k plus 1, so I've got 12 minus k factorial times k minus 1 factorial over 11 minus k times k factorial. Now that is the same as negative 3 on 2. 12 minus k factorial is, and I've actually got a factorial here that I didn't put in, so I better put those in. 12 minus k factorial is 1 higher than 11 minus k factorial, so I can write that as 12 minus k times 11 minus k factorial, so that's for that bit, is there, times this k minus 1 factorial over 11 minus k factorial. Now k factorial is 1 higher than the k minus 1 factorial, so that's k times k minus 1 factorial. Now we can do some cancelling, and we get negative 3 on 2, and the 11 minus k factorials cancel, and the k minus 1 factorials cancel, and we're left with 12 minus k over k. And I still have this x cubed here over x cubed. So now I want to look at just the coefficients, okay? So for the greatest coefficient, we know that t to the k plus 1 is greater than t to the k, or t to the k plus 1 over t to the k is greater than 1. I'm just doing the coefficients now, so I'm leaving out that x cubed. Now, this question is slightly different. If you look up here, we've got 2x squared minus 3 over x to the power of 11. And notice that each term, if I was to write the expansion of this out, the first term would be positive, the second one would be negative, the third one would be positive, the fourth term would be negative, and so on. So what we need to do to find the greatest coefficient, what we really want is the greatest, absolute value of the greatest coefficient. So what we need here, we know that for greatest coefficient, t to the k plus 1 is greater than t to the k, or t to the k plus 1 over t to the k is greater than 1. But if one of these obviously is going to be a negative, so this won't be the case. So we need the absolute value of t to the k plus 1 over t to the k is greater than 1. Now, remember, we're just looking at the coefficient here. So please, where you've got a plus here, as in the first example that we did, you don't need the absolute value thing. But where you've got a positive, and where if you were to write out the expansion, you've got a positive term, a negative term, a positive term, a negative term. This here, if you keep this all, if you don't take the absolute value here, one of these is going to be negative, and you're going to end up with a value of k that is actually way bigger than 11. You know that k has to lie between 0 and 11, okay? It can't be greater than that. So I'll just do the coefficient now. So the greatest coefficient you have to find the absolute value of this. It's greater than 1. And just putting our result in, we've got absolute value of -3 times 12 minus k over 2k is greater than 1. Now, so we just get rid of this negative here. It'll be 3 times 12 minus k over 2k is greater than, sorry, that's meant to be a 1 there, is greater than 1. So therefore we've got 36 minus 3k is greater than 2k. And so we've got 36 is greater than 5k. And so k is less than 36 on 5, or k is less than 7 1/5. And so therefore k must equal 7. So k equals 7 gives us the term with the greatest, I'll just put absolute value of coefficient. So therefore, this will be the 8th term, t of 7 plus 1. Remember, it's t to the k plus 1, so it's the t8, which is the 8th term. So therefore, t8 is going to be, now I'll just write out what my the binomial product is. It's 2x squared minus 3 over x to the power of 11. So therefore, the 8th term, which occurs when k is 7, is going to be 11c7 2x squared to the 11 minus 7, which is 4, minus 3 over x to the power of 7. So it's 11c7. Again, we've got 2 to the power of 4, x to the power of 8, times -3 to the power of 7, times 1 on x to the power of 7. So it's going to be 11, so I've just broken these up. 11c7, 2 to the power of 4 times -3 to the power of 7. x8 on x over x7 is x. So therefore, just working that out, this is the term with the greatest coefficient. Therefore, the absolute value of the greatest coefficient, but I'll just write greatest coefficient, but it is the absolute value. The absolute value of it is -11,547,360. Okay, now let's say you did not do the absolute value up here, that you forgot to do it. This is what will happen. Okay, so we had -3. Now, just a typical error that you can make, -3, 12 minus k over 2k is greater than 1. If you do not take the absolute value, then this is what you'll get. -3 times 12 minus k is greater than 2k. -36 plus 3k is greater than 2k. And so we get that k is greater than 36. Now, obviously, this is not a solution, okay? Because this is your binomial product to the power of 11. So k is a maximum of 11. You're getting k is greater than 36, or k is 37. So this is incorrect, okay? The reason is you must take the absolute value of that, okay? Must take absolute value. So this is obviously a negative expression. You don't go changing this negative here too. This is negative all of that. So it just becomes, when you take the absolute value, it just becomes 3 times 12 minus k over 2k is greater than 1.